Good morning and welcome to today's lesson. Today we're going to continue with what we were doing yesterday. And then we will look at what we are going, the topic for today. You remember, we're looking at balancing of what chemical equations. So, and then somewhere we were not done. So we'll just continue from where we left off. And then if you can remember, I gave you a homework of which I assisted you to answer question 1A. So I'm now going to wait for B. So may you please type in your answers for question 1B. And the whole question is talking about potassium chlorate decomposing to give potassium chloride and oxygen gas. So A, you are supposed to write a word equation for the reaction, and then B, you are supposed to write a balanced chemical equation for the reaction. All right, so please send in your answers before we go on. I'm waiting for you. Let's be fast, let's be fast. Are you hearing me, guys? Learners, are you hearing me? I'm waiting for your answer for question 1B. Okay, let's see. We did not. I wrote the word equation for you. Now I'm looking for a balanced chemical equation for the word equation that I wrote for you yesterday. So we did for the word equation. I gave you a homework, but you never worked on it, or you never did it. So I assisted you to do number 1A for you. So I'm waiting for you to do 1B, of which I gave it to you as a homework. So let me know I'm waiting, please. Send in your the answers. Send me your answers to 1B so that we can proceed. Okay, yeah, Nosipo. Yeah, that's good. I'm waiting for others. I can see this one for no SIPO. Yes. Are you telling me it's only no SIPO who did that? My learners, are you telling me it's only no SIPO who did that? Okay, Onka. All right. I have Onka. I also have no SIPO. Onka, may you check your product. One of your product is not balanced. All right. So okay. All right. We cannot wait for the rest of you. Now let's go to see the corrections. All right. So this is perfect. So the word equation, the one I wrote for you yesterday, potassium chlorate will decompose or break down to give you potassium chloride plus what? Oxygen. So this is the word equation. And when we then come to the balancing of the equation, I also left out 2 here. Yeah, so it's supposed to be 2 potassium chlorate will decompose to give potassium chloride and then what? Oxygen. All right. So if I check, if I check is if I check here, is going to be uh, all right. No problem, Paul. No SIPO is well balanced. Then Onka, you're supposed to put 3 in front of oxygen as one of your product. All right. Okay, so let's continue with the balancing. Okay, now, so even though we are going to look at formation of rust, I just want to leave it for now and then we'll continue to balance. So this was what we were supposed to do yesterday. Now we're going to continue with the task. So you have an activity here. The activity, we are using pictures or models to represent it. Now we're supposed to answer task 1, then and task 2. So we're supposed to task 1 for each reaction, we are going to write the chemical equation. So these are symbolic um, models or pictures, if you say so. So we are going to look at them and write a chemical equation for 1 and 2. That is for task 1. And then when we go to task 2, we are going to say, state whether the equation is balanced or unbalanced. So you have to state that. Then, and give reasons for your answer. If you say it's balanced, you have to give reasons. If you say it's unbalanced, you have to give reason. So for now, let's just do task 1. Write the equation. So, and remember, each equation is 3 marks. So first of all, let's do it step by step. You write the answers for task 1. So write the chemical equation. So you look at the diagram and then you write out an equation. So for now, we are just writing the equation. Then after we'll talk about whether it's balanced or not. So let me see. If you are sending me your answer, send me private. Send me private. Don't send it to everyone. Oh, okay, I do understand. Sometimes the internet connection sometimes can disappoint us. No problem. I do understand. So if you are going to send me your answers for this, send me private. Don't send it to everyone so that they can just copy and then give me the same thing. So let's get going. So what we need to do, study the reaction diagrams carefully, write the chemical equations for each reaction, and you are supposed to use this format: reactants on the left hand side, and products on the right hand side. Reactants on the left hand side and products on the right hand side. Okay, so let me see. Um, Now see, they said chemical equation. Tando, Tando, you are giving me a word equation. It's saying chemical equation. So you use the symbols. I can see that one for onga. Um, Onga, remove the 2 from the oxygen at your product. Rewrite it again for me. And when you rewrite it, you remove check very well. Check very well what you are seeing. Onga, write it again. Check very well what you are seeing in that one, in equation 1. What you are writing is not what you is here. So double check and write it again. All right. So you don't use a word equation, use a chemical equation, meaning you are supposed to use the symbols. Yes. Yeah, Uncle, you. Uh, I saw you writing with your. Oh no, it's Tando. Tando. Tando, go back to the diagram. Very good. But rewrite it again. Rewrite it again. And then what you have just sent, rewrite it again with what you have sent. Again, completely in line. Try to do it in, don't do it in bits. So if I ask you to write it again, you make sure that you write the whole equation and then fix the other one that you are correcting. Okay. Yeah, that's perfect. That's what I want you to do, Tando. That's good. Onka, also do the same thing. Make sure that the reactants are there and the product as well. But you must, so Tando, you are correct. So you have a mark, we have got 2 reactants. So you have 2 marks there, 1 for each and then 1 for the product. So you are fine. So you have got 3 out of 3. Okay, for equation 1. So let me see who's else. Yes, Onka, that's perfect. Thank you for listening. Um, I'm waiting for the others to make a comment before we go to the next. We are many today, but I can only see. Hey Kai, I can only see few. No see Po Kai, but Kai Mpo. So send in your answers so that I will comment before we move ahead. Okay, Mitch is here, Tando is here, Tandy is here, Snolwazi, Onka, Ongatse, Mpo, Kamo, James, JPM, Cleo, Charlton, Kai, Adias. All right. Okay. So let me see. All right. Onka, all right. Okay. Onka, yeah, you also got 3 out of 3. Okay, for the first one. So you are already in the second one. Okay, now that's cool. All right. But you must say, we are doing the one on the screen, Cleo. We're supposed to do this one yesterday. Now, on cam, you are not giving the reasons. If you go to task 2, it says state whether it's balanced or not. And if you say it's balanced, you give a reason why it's balanced. If you say it's not balanced, you give a reason why it's not balanced. So make that statement before. Look at what you have written first and tell me, is it balanced or not? You must make that statement. So, and any of them, we're supposed to write for the two. We are writing an equation for one and an equation for two, or you are writing for the two equation. All right, but I can see that you are saying the one is balanced. You're supposed to write you're supposed to just write one, the equation one and two. Then when we are talking of balancing, when we come to task two. Okay, yeah, Tando, that's good. Task one, which one are you talking of? Is it equation one or equation two? Is unbalanced. They're supposed to have two oxygen on the product. Perfect. That's a reason. That's a good reason, Tando. Very good. That's what I want you to say. So if you say, so you are now giving me for task two. Very good. The second one is balance. All right. Okay, now that's cool. All right, let's keep them coming. And Cloney, what are you saying? Okay. All right. Perfect. I do understand that everyone is at least having an idea as to what we are doing. Okay. That's perfect. All right. So all right. Now let's proceed. That was a good job done there. So you all got it right, except some few. All right, let's continue. Okay, let's look at, now we have to work with task two. Study your two chemical equations carefully. Using what you learned in the previous lesson, decide whether or not each equation is balanced. You will find that one of the equations is not balanced. Explain what was done to balance the equation. The answers to the questions are provided below. Let's check your answers. Now, so this is what you were doing. We are now doing the corrections to the previous one. Okay, if you look at chemical equation one, we were just supposed to write. So you just write it, okay? And then equation two, we were supposed to just write. Look at the diagram and write. So if you look at the first diagram, is one magnesium and then two oxygen, giving us magnesium and oxygen. So when we look at the picture, this is what we were seeing, and this is what we have to write. We go to equation two, we have got two magnesium, we have got one oxygen gas, and then we have got what? Two magnesium oxides. Perfect. So if you are able to do that, you get 3 marks each. So 1 mark for each reactant and a mark for the product. Now, when we go to task 2, if you look at a chemical equation 1, this equation is not balanced. Then this is the reason. Although there is one magnesium atom on each side of the reaction arrow, there are 2 oxygen atoms on the reactant side, but only 1 oxygen atom on the product side of the arrow. Okay, so you will see that it's not balanced. So if you state that the equation is not balanced, that's 1 mark. If you explain why, then you get 2 marks. So that's 3 marks. Then let's go to equation 2. If you state the equation is balanced, that's 1 mark. And then when you explain, you get 2 marks. So there are 2 oxygen atoms on the reactant side and 2 oxygen atoms on the product side. There are 2 magnesium atoms on the reactant side and 2 magnesium atoms on the product side. Okay. An additional magnesium was added in order to balance the equation. So that's perfect. All right. All right, so let's continue. Okay, so this is what we were supposed to do. All right, now, so this was supposed to be a homework for yesterday, but we never reached here. So I want you to balance this equation. So we are going to do it here. So look at the equation on the board or on the slide or on your screen. We are going to what? Balance those equations. I hope you are following. So another two equations to balance, you must take time. What needs to be done to balance the following equations? So you have to, they are not balanced. So what needs to be done to balance them? Okay, so A and B. So let's go on again. Let's be fast. Let's be fast. Let's be fast. Get busy, get busy, get busy, get busy. All right, so let's go on. All right. Onka. All right. Okay. Onka, I tell you, always send me a private. Tando, you are correct. But the question says what, so now what needs to be done? So what you have balanced, what you have done, you need to explain. So you have balanced it. So what did you do? What did you do to make the equation balance? So try to explain it. All right. I give you the next 3 minutes for us to finish and then move to the next. I give you the next 2 minutes to finish. Yes, I'm waiting. All right, let's keep working. Yeah, perfect. But Cleo, I didn't see your balance equation, but you have done that. That's a good explanation. Okay, that's perfect. All right, so let's go to equation 2. So the equation 1 is talking about what? Sodium reacting with oxygen to give sodium oxide. And equation 2 is talking about ammonia reacting with chlorine gas to give us nitrogen gas, and then what? Hydrogen chloride. Okay. So what do you have to do to equation 2 or B to make it balance? So here you have to open eyes. You have to open out your eyes so that you can see what you need to do. But you can do it since you are busy managing and balancing the other equations. You will be fine. All right, let's get going. Let's push, let's push, let's push, let's push, let's push, let's push. Let's push, let's push, let's push, let's push. I know you are busy calculating to give me the coefficients and as well as your explanations. All right. I'm waiting. Let me see who is done for equation 2. Yes. Cleo, are you there for question 2? Tando, are you also there? Onka, are you also there? Tony, are you also there? Mpo, are you also there? Let's make it quick. 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 Oh, okay. No problem. Yeah. Clear, no problem. I do understand because you need to balance it by putting in the correct coefficients. So otherwise, if you don't get the correct coefficient, then you will not be able to balance it well. So keep on. All right, let's push on. All right, slowly, but yeah, I do understand, but you can just try it. Try it. If you don't understand, then you will listen again. All right. Okay, it's like this one is a tough time. It's giving you people tough time, ne? All right. So let's see what you were supposed to do. This is what you are supposed to do. It says what needs to be done to balance the following. Okay, let me see. Somebody has just sent in. Yeah, you can speak. Okay, so let's continue with, so this is what you needed to do. This is the question and answers. So by changing the number in front of sodium to 4, then another 3 sodium atoms are added to the what reactant side. By increasing the number in front of sodium to 2, another 2 sodium atoms are added, and 1 oxygen atom is added to the what product. That is what you were supposed to say. Okay. All right. Then let's go to B. What happens in B? Yeah, so this is the balance equation. So by changing the number in front of, now we are talking of this. By changing the balance equation for A is this one. Most of you got it. And by changing the number in front of ammonia to 2, 1 nitrogen atom and 3 hydrogen atoms are added to the reactant. And then by changing the number in front of chlorine to 3, 4 chlorine atoms are added to the reactant side. By increasing the number in front of hydrogen HCl, hydrogen chloride to 6, another 5 hydrogen and 5 chlorine atoms are added to the product side. So the balance equation is like this. So those of you, I know it was a bit of a tough time. So the balance equation will be what? So ammonia will have a coefficient of 2, chlorine 3, and nitrogen will be 1, and hydrogen chloride will be what? 6. So we can say the mole ratio for this equation is 2 is to 3 is to 1 is to 6. Okay. All right. Yeah, exactly. Where does the 4 come from? The 4, yeah, if you look at your product side, that's what this one explains. That's what Onka explained. Yeah, because if you look at the product side, you see that you have got 2 times 2 will give you 4. 2 times 2 will give you 4. So when you go that side, so originally it was 1, so you have to write the 4 here. So when you write 4 here, this will be 4, this will also be 4. And then this will be, this is 1, so it's 2 times 1 will be 2, so it's balanced. Okay, now also look at, yeah, also look at the last equation and then ask a question, why is this one like this before we can continue? So just like Ongase, you didn't understand and you asked. So also look at, peruse it well, and then you can ask your question. So before we can proceed. All right. Okay, then let's proceed. So we are just done with the continuation of the lesson for yesterday. So we're going to look at what? Uh, the lesson for today. Now, so since we're talking of a balance equation, so you have realized that when we are balancing equations, we must make sure that the number of atoms on the left-hand side should be equal to the number of atoms on the right-hand side, or the number of atoms on the reactant side should be equal to the number of atoms on the product side. Perfect. All right. Now let's go on. So today we're going to look at the word formation of rust. So formation of rust is also another kind of what? Chemical reaction. So it's a kind of chemical reaction. Okay, so formation of rust. So formation of rust is also another form of what? A chemical reaction involving a metal and then oxygen and water. So when you leave a metal outside for a long time, you see that because of the oxygen in the atmosphere, the metal will react with it, and in the presence of the what? Moisture content in the atmosphere, then what you do is that, or what we can then be happening is that the oxygen with the metal in the presence of the water or moisture will turn that metal around to into from its original color to a brownish, which is what, like a chemical reaction, because it's wearing away of the what, metal. So that is just a background now. So let's look at formation of rust. Rusting is a slow chemical reaction of iron metal with oxygen and water. Now take note, without some of the factors involved, then rusting cannot take place. It must be in the presence of oxygen and also water. But if there is water, then one cannot occur. So a complex compound is formed as a result of the what reaction. Part of the compound formed is iron oxide, FeO3. Rust is a form of what? Corrosion. We can prevent the formation of rust by painting or electroplating a product which contains what? Iron. So meaning, if I have an iron and then I know that it will rust, then I have to paint it like an oil paint so that the oxygen and the water might not react with it well, or I electroplate it. Electroplating is simply talking about what? Coating a metal object with a thin layer of another metal by means of what? Electrolysis. So we have to check which of these elements or which of the elements can be used to electroplate this. Okay. Then electrolysis is the process of dipping an iron or steel object in a zinc base or aluminum base. All right, I guess you are following. All right. Now, if you are listening, rusting is a form of corrosion. True or false? Send in your answer for me to see if you are listening. Rusting is a form of corrosion. True or false? Okay, let's see. Yeah, fantastic. Now, name the two factors which will influence rusting. Name two factors. Without them, rusting cannot take place. Yes. Name two factors. Without them, rusting cannot take place. Oxygen, water, and moist. Yeah, fantastic. So the correct answer, water, air into bracket, oxygen, or you just say moisture and oxygen. Perfect. All right. Now we have got 5 minutes left. So let's see whether we can go and play Kahoot. Now let's look at this. All right. Now since materials or metals rust is a problem, so we have to find ways of what? Trying to solve that problem. So rusting is a form of corrosion. We are already aware of that. And corrosion is the gradual destruction of materials due to what? Chemical reaction. Some metals, for example, iron, corrode easily. Rusting usually makes the object or material useless. For this reason, we try to prevent what? Rusting. So why do we try to prevent rusting? We try to prevent rusting because when it occurs, it makes the object or material to be useless. Now, water and oxygen are needed for iron to rust. We can use this knowledge to prevent what? Rusting. Now, let's look at the problem of rusting continues here. When iron reacts with water and oxygen, it forms iron hydroxide. When the iron hydroxide dries out, the water is lost and then iron oxide is formed. We can prevent rusting by painting iron because the layer of what paint prevents water and oxygen from coming into contact with the iron. Electroplating is the process of coating a metal object with a thin layer of another metal by means of what? Electrolysis. Electrolysis is the process of dipping an iron or steel object in a zinc-based or chromium-based solution through which an electric current is passed. The zinc or chromium atoms then are deposited on the surface of the iron or metal. Not only do painting and electroplating prevent the rust reaction from occurring, they also improve what? The appearance of the object. Perfect. Now, thank you very much. Uh, if you have any questions, you are welcome to ask. All right. So I just quickly want to switch to Kahoot. We play a game there based on what we did yesterday and today. And then I'm sure you are seeing the screen. If you are seeing the screen, just let me know. Are you seeing? Oh, you didn't get the email. All right, then I will check. I did mark it. I will send it to you. Okay, if you can see, now let's play the game. All right, so let's go on. A bit patient is loading up. Okay, so yeah, get ready to join at www.kahoot, or if you have the app, you may key in. This is the code. The code is 549994. Okay, James is here. Anka is also here. Cleo is here. Your book is Sky is also here. I'm waiting for others. All right, so let's start the game because the time is almost up. 2, 1, 0. Let's get going. We can change the subscripts while balancing equations. Examples: true or false. H2O can be changed to this, true or false. Yes, it's false. We cannot change the when in the equation. If the way the equation is given to you, you cannot change it. So that's why it's false. Let's go to, okay, only two people got this one right. Let's go on. Who discovered balancing equations? Dr. Seuss, Jean Benguin. Yes, only one. Oh, all right. It's so short. Let's go to the next. When balancing equations, you may change subscripts, coefficients, both subscripts and coefficients, neither subscripts nor coefficients. Yeah, coefficients. 5 got this one right. Let's go. Perfect. Let's get going. Balancing equations. So which numbers are you supposed to write so that you can balance the equation? So just check it well. So you have ammonia reacting with copper oxide to give copper, something to give copper, nitrogen, and water. So what is it? Okay, the code is 549994. Those people I just sent it. I hope you can get it. Okay, let's be fast. So which coefficient are you supposed to use for the equation to be balanced? Yes, let's get going. All right. Yes, only one person got this. So these are the coefficients 2, 3, 3, 1, 3, and then the equation is balanced. So let's go to the next. Okay, let's go to the next the time. Otherwise, they will log us out here. Balancing of chemical equations. Okay, 3 people got this. Balancing of chemical equations is based on what? Law of conservation of mass. Let's go on. Okay, let's go on. When balancing equations, what does the arrow mean? Subscript, product, yield. It is just an arrow. Okay, yeah, yield. Okay, Let's go on. When applied to balancing, what happens? Fantastic. Yes, number of atoms should be equal to what number of products. Let's go on. Okay, so the scoreboard is there. Let's go to the next. Okay, when balancing equation, you can only add a factor in front of an element or product. That is true. Let's go on. Yeah, Cleo is there. Okay, we are left with 3 questions to go. The time is almost up. In fact, it's up. Balancing equations follows the law of what? Dalton or Lavoisier, and is known as what? Okay, conservation of matter. Perfect. Let's go to the next. We are almost there. Question 10. Okay, chemical equations are written. In which way are chemical equations written? Perfect. 5 people got this one right. Then let's go on. Balancing chemical equations is called stoichiometry, true or false? True or false? Yeah, that's true. Only 2 people got this one. Yes, the last question before we go is almost time. Let's play that one and then we are done. When balancing chemical equations, what is the first step? Placing coefficients, placing subscript, counting atoms, screaming in frustration. Which one is the answer? Yes. Okay, very good. It's counting the atoms first. Very good. So let's see the scoreboard. I mean the one who Pam got 6 out of 12. Onka 7 out of 12. And Cleo got 10 out of 12. Okay. Well done to everyone. And thank you for coming around. Enjoy the rest of your classes. The time is up.